an example that is used to calculate the sum of finite series using the method of differences. It's basically you are saying we have got some series that can be expressed. Say if a series can be expressed in the form f of r minus f of r plus 1, this type of a series, then the sum of this series can be found because there is a pattern that is going to be derived from this form. The sum of the n terms can be found by saying summation of f of r minus f r plus 1, like this. So a better way of looking at it, you are simply saying, imagine you have a function or a series, say for example 4x squared, and you are choosing to write it. It can be expressed as a form of two other functions, say for example 3x squared plus x squared. So this is the form we are referring to. Or maybe it can be expressed as, in this case, let me be consistent with 5x squared minus x squared. Then you can find the series by using this form. Okay, so let us look at this example, which says express this function, which is a fraction, in partial fractions. The method of partial fractions is known to all now, which is, you are simply going to say this is equivalent to 2r plus 1, r plus 3, which is equal to a over r plus 1 plus b over r plus 3. This further implies that 2 is equal to a, r plus 3 plus b, r plus 1. So we can eliminate a or b in trying to find the actual values that represent a and b. So to eliminate a, I can actually say, okay, let me start by eliminating b. I can set r to be equal to minus 1, because if I put a minus 1 here, this whole function part here becomes 0. So we are going to have 2 is equal to a minus 1 plus 3, which is just 2 is equal to 2a, suggesting that a is equal to 1. And if I want to eliminate a, I will have to set r to equal to minus 3, which means if I put a minus 3 here, this part here becomes 0. So I'm going to have 2 is equal to b minus 3 plus 1, which is just minus 2b equal to 2. So the value of b is equal to minus 1. So this takes us to the equation that say to this form, which means a is equal to 1. So this can be written as 1 over r plus 1 minus 1 over r plus 3. Now we go to the part that is important, which is find the sum by using a method of differences. So using this method, which we call the method of differences, using the method of differences, we can see that when r is equal to 1, if I put a 1 here and there, I'm going to have 1 over 2 minus 1 over 4. And when r is equal to 2, if I put a 2 here, I'm going to have 1 over 3 minus 1 over 5. And when r is equal to 3, I'm going to have 1 over 4 minus 1 over 6. It's clear if you look at the pattern. The numbers on the left hand side is 2, 3, 4. Then this is 4, 5, 6. So I can keep going. I know that this is going to be 5. I know this is going to be 7. I can keep going from there. So the last term which is n, will be, since this is a 4 and this is a 5, it means the last term which is n will be n plus 1. And this is going to be 1 over n plus 3, because from 4 to 7 is 3. We're adding 3. And the term before r is equal to n is n minus 1, will give us 1 over n. Then this one is going to be 1 over n plus 2. If you look at this pattern, you will see that there are numbers that are cancelling. We can see that this 4, 1 over 4 cancels with this 1 over 4. 1 over 5 cancels this 1 over 5. So if 4 was the last term, it means the sum of this function, this fraction, is just equivalent to adding these two numbers and these two numbers. That's what it means. So if we continue with this up to n, based on this, we are sure this will be cancelled. So the only things that are left are these two. So that means the sum of 2 over r plus 1, then r plus 3 is equivalent to saying 1 over 2, this 1 over 2 here, plus 1 over 3, this is here, minus 1 over n plus 2, then minus 1 over n plus 3. This translates to become
the Beacons program for year 12 is starting now in the Ruhr Hall. So that's the Beacons program for year 12 is starting now in the Ruhr Hall. Thank you.
This translates to 5 over 6, 1 over n plus 2, minus 1 over n plus 3. So you can simplify this by just looking for the common fraction, common denominator, which is 6n plus 2 and n plus 3. Then the numerator can become whatever you want it to be, but in this case, it will reduce to 5n squared plus 13. Then if you factor out 13n, if you factor out the n as here, this is going to become 5n plus 13 all over 6n plus 2 n plus 3, suggesting that the value of A is 5 and the value of B is 13. To add the sum from r is equal to 21, so if we are to add the sum from r is equal to 21, we now have the formula already. So from r is equal to 21 to 30,